Okay, so today we're going to do right triangle trig application. So we're going to be doing the same thing that we did yesterday or the last class, where we're going to use the SOHCAHTOA or the trig ratios to help us find missing angles or sides. But now we're going to do it in word problems. So we're going to kind of look at word problems, draw a triangle, and use that triangle to help us find missing sides and angles. So one thing that you want to be familiar with are angles of elevation and angles of depression. So a lot of times our word problems will talk about when somebody's looking up to a tree or looking to the top of a building. When you're looking up, that's considered an angle of elevation. So if you're a person standing down here and you're looking up, this here is your angle of elevation. So when you're drawing a triangle and they talk about somebody looking up, you'll mark that angle on the bottom as the angle of elevation. When they're talking about an angle of depression, that's the angle that's formed by looking down at something. So maybe you're at the top of a building looking down at a car or something like that. And your angle of depression, this one gets a little bit more confusing. So if you're standing up top and your angle of depression down, that's this angle, because it's kind of like if this is where my eyesight is and I'm looking down, this is my angle of depression. So maybe I'm looking at a dog that's down here. This would be my angle of depression. So now if we think about it, this here is my sight line out, and this is the ground. These two things are parallel. These are parallel lines. And last year you learned about alternate interior angles. I don't know if you remember that. And what we know about alternate interior angles is that this angle here is congruent to this angle here. So the angle of depression is the same thing here, is also this angle. So these two things are congruent. And you'll see that I'll mark it on our figures. So we're going to do a few examples here. I'll do the first example. And the big thing with these examples is that you need to draw a triangle. So it says a man is 6 feet tall and is standing 50 feet away from a tree. So I have a guy, he is 6 feet tall, so I know that his height is 6 feet. And he is standing 50 feet. So that means this is going to be 50 feet away from a tree. So here's my tree. And when he looks up to the top of the tree, so we're thinking here, so when he's talking about looking up, so when he looks to the top of the tree, we're thinking angle of elevation. So he's looking to the top of the tree. And it says his angle of elevation is 42 degrees. So that tells me that this is going to be 42 degrees. And actually, I want to change this because it says he's looking up. So we're going to assume that that's coming from his eyesight here. And they want to say, what is the height of the tree? So the unknown, the thing that we're looking for is the height of the tree. So what we have here is we have a triangle. Our triangle looks like this. We have 42-degree angle of elevation. We have a right angle here. We have H is what we're looking for. The bottom here is 50 degrees. The 6 feet is going to come in when we're talking about the height of the tree. We know that part of the height of the tree is that 6 feet for how tall he is. So we're really looking for the height of the tree is going to be really this distance here, from here to here. That's our H. So once we find H, we'll just have to add the 6 feet for how tall the guy is. So we're going to use SOHCAHTOA now. This is the angle I have. Label my sides. This is adjacent. This is opposite. So which of the trig functions uses adjacent and opposite? That would be the tangent function. So I'm going to say tan of 50 degrees. Or I'm sorry, this isn't degrees. I don't know why I put that. Tan of 42 degrees is equal to opposite, which is 8, over 50. So we're going to cross multiply. So I get 50 tan 42 degrees equals h. And I can do that on my calculator. So I'm going to get 50 tan 42, and I get 45. So the h is 45 feet. So that means this part is 45 feet. Plus we need to add the 6 feet for how tall the guy was. So how tall is the tree? The tree is 45 plus the 6. So the tree is going to be 51 feet. Let's do one more here. So this one is talking about a person at the top of the Eiffel Tower looking down. So when I see looking down, I'm thinking angle of depression. So if I draw it, like I said, it's super important to draw your picture. So let's say this is my, well, that's a bad Eiffel Tower. Let's do it like, here's my Eiffel Tower. There's someone standing at the top of the Eiffel Tower. So they're here at the top and they're looking down and they see a tour bus. So they're looking down and they see a bus. And it says if the Eiffel Tower is 324 meters, so we know that the Eiffel Tower here, I'm going to draw my triangle. This is going to come down. This is going to come over. Here's my right angle. I know that the height of the Eiffel Tower is 324 meters. And the angle of depression, so when they look out, this angle here is 31 degrees. But we know that these two angles are congruent, so that means this is 31 degrees. Okay? A lot of people make the mistake of saying that this is 31 degrees. That's not the angle of depression. You got to think when you're looking out, you start level and look down. Okay? So the angle of depression is this angle in here, which is the same as this angle down here. So we have this triangle. If I kind of draw it separately, the triangle that we have, it's a right triangle. This is a height of 324. This is 31 degrees. And the question is asking how far are we from the base of the Eiffel Tower? How far is the bus from the base? That's going to be our x. So we're going to once again use SOHCAHTOA. I'm going to highlight the angle I know. I have the side opposite. This is my opposite. I'm looking for the adjacent side, which uses opposite and adjacent tangent. So the tangent of 31 degrees is equal to opposite, which is 324, over adjacent. I go ahead and I cross multiply, and I'm going to get x tan 31 is equal to 324. So x is equal to 324 all over the tangent of 31 degrees. Which if I do that on my calculator, I'm going to get 518.5 feet. So how far is the base of the, how far is the bus? The bus is 518.5 feet. That's my final answer. So we're doing the same thing as we did in the homework, but you have to make sure you draw your triangles. I'll do another video for the last two examples.